Structured programming is a common programming style, particularly within the C language. Its primary purpose is to break up large programs into smaller chunks of related code. This is called modularization. This short, modular code is better than towering monolithic code for a variety of reasons. First, it separates a large, complex problem into smaller, more manageable problems. Each part of the code can focus on one of these problems. This makes the program far easier to write. Program requirements that are as broad as write code that manages billing a customer at a restaurant get simplified to a group of far less complex tasks, such as write code that requests input from a user. So, modularized code helps us break down a challenge to make it easier to approach. An additional benefit of this is that when someone else looks at the code for your billing management system, they aren't confronted with 1,000 lines of code. They're presented with maybe 10 functions, each of which is 1/10 of the size and complexity of the whole. This is far easier to approach. And each of these functions, which are perhaps only 50 to 100 lines long, have been reduced to a single statement in the main function. If you look at the sample code, we have a function with 3 long lines of code. By grouping it into a function, we can compress these lines into one command. And the great thing about this is that now you can use this command whenever and wherever you like. No need to copy and paste those 3 lines everywhere. No doubt you're wondering what the big deal is. You'll be copy and pasting this one line now instead of 3. Isn't that basically the same thing? Well, there's an easy way to answer that question, and it's by asking you another question. If you had these 3 lines of code in 20 places in your main function, how would you go about changing these equal signs to something else, like asterisks? Maybe you'd go in manually and change each offending line of code. But if it's modularized the way it is here, then all you need to do is change 2 lines of code. So functions allow us to make large changes to our program without having to take a 3-week tour of the source code. Changes are made easily and without complications. And going back to our hypothetical program with 10 functions, the poor muggins that has to read it can see these function calls and tell by the name what it does and whether or not it's important. They only need to read the details that they're interested in. If they don't need or want to know how this Hello World message is printed, then they don't need to read that code. They can just see the function call and know that there's a function that prints Hello World. And of course, one of the best benefits of doing things this way is that you can easily pluck out a function from one program and use it in another. If you want to print out Hello World this way in another project, you can just copy the function definition to your new program and call it from there. So, structured programs are really nice, and they're really very easy to use. Remember, the function has a type and a name. The type indicates what sort of data it provides, if any. The name is followed by a pair of parentheses which contain any parameters the function should take. To call this function to be executed, we just write the name and any parameters it needs. With all this in mind, let's quickly look at printf. Printf is itself a function. It's a name followed by parentheses, and inside those parentheses is a parameter, the text we want it to output. You can be sure that actually doing this manually would be quite complicated, but because it's a function, you don't need to worry about how to print something to the screen. You just call the function and let it do its job. Consider the sample code in C Basics for finding the minimum and maximum of 2 numbers. This code can be used multiple times in a program to find the minimum and/or maximum. The frequently used code in this program can be defined in a function to make it easier to use. Let's create a new function called max. Max won't be void because it needs to return the result. The result will be the larger of the 2 numbers, so its type should be int. We also need to give it a couple of parameters, the two numbers we're comparing. So all we need to do is declare these variables in the parentheses. Our parameters will be int n1 and int n2. It's worth bearing in mind that these parameters and any other variables written here are local to the function. No other code can access what we work with in here. Likewise, this function has no access to the data in main. Currently, we can only send data to functions by passing in variables as parameters. There is another way to do this, but we won't look at that until a later video. So now that we've set this up, we can quite happily use max as many times as we like. We can even stick different things in and get different results each time. Moving on, the return value of this function can be assigned to a variable. The equals operator in C is used to assign a value to a variable. The variable on the left side will assume the value of what's on the right. The line int max equals max AB will create a variable called max and then call the max function, passing in a and b as parameters, and what this function returns as its result will be assigned to the value of the variable max. Remember, this works because max returns an integer. If this were a void function, it wouldn't work. In the sample code, we also have implemented some average, odd, and digits functions based on the code from C Basics. We can pass any pair of numbers to average. The parameters n1 and n2 in average are initialized with different values in each call. Since average prints the data to the screen, we might decide to call it just for that purpose. We don't have to use its return value. If we look at the code that runs when we call average, we notice a problem. It performs all its calculations with integers. That means if we try to average 5 and 10, we'll get 7 instead of 7.5. We have a different version of average called average f that resolves this problem by using floats instead. In addition to changing the type of the variables, we should change any constant numbers to be explicitly decimal numbers too. So 2 should be changed to 2.0. When you have a lot of functions in your program, you might find it easier to navigate around using the class view. The class view displays all the functions in your program. If you double-click on the function name, it'll take you to that function's definition in your code. As an exercise, try to write some new functions. Try one that asks the user for a number and checks to see if they are even or odd. And here's another idea. Write one that gets a number from the user and outputs the digits individually. This function should also check to see if the number has 3 digits, and if so, repeat the process.